Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about inversion count efficient code. This is a medium level question. So, in order to solve these questions, you should have some basic understanding of the programming. So, this basic level understanding is provided. You visit our website learningmonkey.in. There you have to take the placement training for service based companies. This course, you have to finish that course. After that, you have to come here. The examples which we discussed there will help you to improve your coding skills to overcome the basic level programming. Then we will go with this medium level. So we are going to give an intuition how to write the code for this program, for this problem. You try to solve it on your own, then check for the solution. That is the best practice. We are going to provide the code in our website, but try to solve it on your own. Coming to the question, given inversion count, we will explain the question. Given array of n elements, so they are going to give n elements in an array. Inversion count is counted like this: if a of I greater than a of j and I less than j, then we have to do the count. With example you will get clarity. So let's take 3, 5, 1, 4, 6. These are the elements. For understanding purpose, index values has been provided: 0, 1, 2, 3, 4. See, 3 greater than 5, no. 3 greater than 1, yes. A of I greater than a of j, I less than j. Here I is index value. We need to do the count. So count is 1. 3 greater than 4, no. 3 greater than 6, no. 5 greater than 1, yes. Count 2. 5 greater than 4, yes. Count is 3. 5 greater than 6, no. 1 greater than 4, no. 1 greater than 6, no. 4 greater than 6, no. So what's the inversion count? So total inversion count is 3 value. This is what you have to output. They are going to provide a sequence of numbers in an array of n elements. We have to provide the inversion count. Let's take one more example. 8, 9, 10, 11. What's the inversion count? 0, because everything is in increasing order. But they have mentioned some time complexity. Time complexity should not exceed big O of n log n, and space complexity should not exceed big O of n. N means you can use n extra spaces. At most you can use n extra spaces, and time complexity is n log n. So the logic goes like this. It's very easy. In our basic programming course, we already discussed about data structures. There we discussed about merge sort. Same logic we are going to use here. We need to write some extra code in the same logic. So what's that extra logic? How we are doing that? Let's try to understand. So what's the efficiency of merge sort? N log n. That's why we are using the same logic, n log n. So what's the space complexity that is going with a merge sort? We are using some extra space. N spaces is used extra. So that's why space complexity of big O of n. So let's try to understand how we incorporate this new logic when we are executing the merge sort. How merge sort executes? We are going to divide these into two parts. They divide these elements into two parts. 3, 5, 1, one partition. This is another partition. 3, 5, 1 is again divided into one partition, second partition. 3, 5, 1 partition, 1, 1 partition. 3, 5 again divided into two partitions. 3, 1 partition, 5, 1 partition. After that, now we are going to merge the elements. During the merge phase, we are going to do the sorting order. We are arranging them in sorted order. At this situation, we are going to use some extra space. So these two elements 3, 5 will be arranged in sorted order. So these are arranged like this. Now these two partitions, 3, 5, one partition, one another partition. These two partitions we are going to merge into sorted order. That is what we are going to do when you are in merge phase. Whenever we are doing that, the logic which we used in merge sort is 3 is compared with 1. Which one is small? 1 is small. 1 is this is the extra space we are taking. We move 1 to the extra space. This is the logic we used in merge sort. See the point here, you have to 3 is greater than 1. We have to increase the count. If 3 is greater than 1, automatically the elements present in this partition, the next element will automatically greater than this one, because these two elements are in ascending order. So now how many times we have to improve the count? We have to increase the count 2 times. For 3, 1 time. After 3, how many elements are there? We have to increase those many times. This is the logic we have to apply when executing the merge sort. If the left side partition is having, if this is having greater value, we have to increase the count. So in order to increase the count variable should be global variable. Then only any function can use that global variable. So we have to take a global variable and write this extra logic in our merge sort logic. So now we are going to show you the code, but our suggestion is try to solve it on your own, then check for the solution. Anyhow, this code is available in our website learningmonkey.in. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.